Hello students, in this video I am going to talk about the combinational circuit, that is multiplexer. Multiplexer is also known as data selector or commonly known as mux. Let us start. A multiplexer is a device that allows digital information from several sources. As you can see, digital information from several sources to be routed onto a single line for transmission over that line to a common destination. So this is our common destination. That is why the basic multiplexer has several data input lines and a single output line. Generally, a multiplexer is termed as n cross 1, where n are the number of input lines we have and one output is going to be there. That is 1. Where f is termed as the select lines. The function of select line is just to select that which input signal will be collected across the output signal. And how to calculate the number of select lines? This is the formula for that. That is 2 raised to power of m is equal to n, where m is the number of select lines we have and n is the input signals we have. So this is a common example which I have taken where the number of input signals we have are 4 and one output signal is there. These are the two select lines which will be used for 4 cross 1 multiplexer. So now basically what is the function of a multiplexer? With the input select line we can choose that which input signal will be collected across the output signal. So that means when the select lines are 0, 0, this MP3 player will be collected across the output, that is our surround soundbar. When the input signals are 0, 1, laptop input will be treated as the output. For 1, 0, digital satellite will be treated as output. And for 1, 1, our digital cable TV will be treated as output. So this is the application of a multiplexer. The first example which I am going to take over here is 2 cross 1 multiplexer. Let us discuss the block diagram first. In a 2 cross 1 multiplexer, we can have two input signals termed as A0, A1, one output signal that is Y. Now let us decide that how the select lines will be used for a 2 cross 1 multiplexer. The same formula which I have written over here once again, 2 raised to power of m is equal to n. But now over here, n is equal to 2. Hence, the value of m, that is the number of select lines, comes out to be equal to 1. So that means only one select line, which is S0, will be used for the implementation of 2 cross 1 multiplexer. Next is the truth table and Boolean expression. As we have just one select line, so two combinations can be written. Either select line S0 is equal to 0 or select line S0 is equal to 1. And only one output is there, that is Y. Now let us try to understand that how a multiplexer will actually work. When the select line is 0, that is S0 is 0, A0, the first input signal, will be collected across the output signal. The second case, when select line S0 is 1, second input, that is A1, will be collected across the output signal. And the Boolean expression, as in the block diagram, we were only having a single output. That is why only a single value, single Boolean expression will be written over here. Now, how to write down the Boolean expression? This is very easy with the help of truth table we have. First is S0 0, as I'm going to use the SOP method, that is sum of product method. So S0 0 means S0 bar dot A0 plus S0. Why S0? Because its value is 1. S0 dot A1. So this is the Boolean expression for 2 cross 1 multiplexer. Next, the logic circuit diagram. And also we are just going to use a single hierarchy to implement the logic circuit diagram in all the cases of a multiplexer. Draw the select line, the number of select lines we are having. Right now we are just having one select line. And draw a NOT gate so that you can get the complement of select line, that is S0 bar. Okay, so here we were just having a single select line, so S0, this whole line is connected with S0 and here we have S0 bar. Now let us try to calculate the value. The Boolean expression was S0 bar dot A0. So this is S0 bar dot A0, dot means AND gate. Next is S0 dot A1. So this line is S0. So S0 dot A1 dot means AND gate. And there is a plus in between both. Plus means OR gate. So this is how you can implement any of the logic circuit diagram of multiplexer. And the last but the most important point, always compare the logic circuit diagram with the block diagram. Earlier in the block diagram, I have mentioned two input signals. So let me just draw a block diagram over here. This is a kind of a block diagram we were having earlier. And this is the inside portion of the block diagram. So in the block diagram, we were having two input signals, which are correct, one select line, which is also correct, and one output signal. Hence, we are able to implement the same logic circuit diagram for the given block diagram. Next example is 4x1 multiplexer. So now again, let us begin with the block diagram. 4x1 means we are having total 4 input signals over here, A0, A1, A2, and A3. How many select lines now will be used? Let us use the same formula once again. So now n is equal to 4. 4 is written as 2 raised to the power of 2. Hence, the number of select lines m is equal to 2. So I have taken 2 select lines formed as S1, S0 over here. And only one output will be there, which is Y. Next is the truth table. Now, as we have 2 select lines, so total 4 combinations will be written. 0, 0, 0, 1, 1, 0, 1, 1. So when the select lines are 0, 0, output is A0, 0, 1, output A1, 1, 0, output A2, and 1, 1, output A3. Now let us try to write down the Boolean expression. Once again, students, only one Boolean expression will be written. Why? Because only one output signal is available in the case of a multiplexer. So let us start. 0 means S1 bar, 0 means S0 bar. So we have S1 bar, S0 bar, A0, S1 bar, S0, A1. Why S0? Because S0 is 1. Next is S1, S0 bar, A2. And the last one is S1, S0, A3. So you can compare the same Boolean expression which I have just informed you with the help of truth table. So it actually becomes very easy to write down the Boolean expression just by looking at the truth table. Now the next is logic circuit diagram. So as already informed it to you, try to draw both the select lines initially as it is and then through the NOT gate as well. So I have drawn select lines and through the NOT gate as well, that is S1 bar and S0 bar respectively. So now let us try to calculate the answers for the output Y with the help of Boolean expression which I have just discussed. The first one was S1 bar, so you can see it over here, S0 bar, A0. So the dot was there between all the 3 signals, hence AND gate. Next was S1 bar, S0, A1. Next was S1, S0 bar, A2. And the last one was S1, S0, A3. As there was dot between all these signals, hence we have used all these gates as AND gates. Last but not the least, now there is a plus between all these equations which I have used. Plus means OR gate. So finally, all these 4 outputs will be given as input to the OR gate just to get the final output Y. Let us try to compare this logic circuit diagram once again with the help of block diagram which I have shown it to you. 4 input signals, correct. 2 select lines, correct. And 1 output signal, correct. Hence, this is the correct logic circuit diagram with relevance to the block diagram of 4x1 multiplexer. Now the next example is 8x1 multiplexer. So now in 8x1, total 8 input signals will be there, starting from A0 till A7. 1 output signal is there, which is Y. And now how many select lines? Let us use the same formula once again. And we are supposed to get the total number of select lines to be equal to 3. That is S2, S1, S0. So this is first of all the block diagram of 8x1 multiplexer. Next is the truth table and the Boolean expression. As right now we have 3 select lines, so we are able to write down total 8 combinations. 4, 0, 4, 1, 2, 0, 2, 1, and 0, 1, 0, 1. So for 0, 0, 0, A0, then A1, A2, A3, A4, A5, A6, and for the last value 1, 1, 1, the output is A7. Once again, just a single Boolean expression will be written because only one output Y signal is there. So now how to write down the Boolean expression? 0, 0, 0 means S2 bar, S1 bar, S0 bar, A0. S2 bar, S1 bar, S0, A1. S2 bar, S1, S0 bar, A2. S2 bar, S1, S0, A3. S2, S1 bar, S0 bar, A4. S2, S1 bar, S0, A5. S2, S1, S0 bar, A6. And the last one is S2, S1, S0, A7. So this is the Boolean expression. You can verify. I have already mentioned it over here on the screen. And now this is the logic circuit diagram of 8x1 multiplexer. Again, we will try to compare the logic circuit diagram with the block diagram. Here we have total 8 input signals, A0 to A7. We have 3 select lines, S2, S1, S0, and 1 output signal, Y. So we will try to utilize the Boolean expression that we have just calculated. The first is 0, 0, 0. That is S0 bar, S1 bar, S2 bar. You can see it over here, 0, 0, 0, A0. So all 4 variables are having dot in between all, hence AND gate will be used. Then we have 0, 0, 1, A1, 0, 1, 0, A2, 0, 1, 1, A3, 1, 0, 0, A4, 1, 0, 1, A5, 1, 1, 0, A6, and 1, 1, 1, A7. 1 stands for S2, S1 or S0 accordingly, and 0 means S2 bar, S1 bar or S0 bar accordingly. And now there is a plus between all these variables. Plus means OR gate. So here I have used a 8 input OR gate over here, hence to connect a single output, that is 1. So this is the logic circuit diagram of 8x1 multiplexer. Thank you so much.